Bhagwat. I'm the Gatsby co-founder, and we're here on the first episode of a local dev pod with Carl Sverre, who is the author and creator of SQLSync. Welcome, Carl.
Thank you, Sam. I appreciate it. Excited to be here.
Yeah, thanks for joining us, everyone. Carl, can you talk a little bit about SQLSync and what is SQLSync?
So SQLSync is a database that I like to think of as a database designed for front-end apps. So ultimately, it's magical SQLite. So if you're familiar with SQLite, which is a nice embedded relational database, we run SQLite in the browser and we automatically allow SQLite to be collaborative. So if one person edits a SQLite database running inside SQLSync, everyone else connected to the same database will see those changes. So yeah, so it's collaborative, local first SQLite.
One question that comes to mind is why is this useful?
Yeah, so I definitely come from a place of building front-end applications. More than 10 years ago, I worked at Mixpanel where I did a lot of front-end app development, and I was really focused on data viz and thinking about how to visualize complex data models. I then spent about 10 years working at Single Store, which used to be called MemSQL, which is a distributed sort of scalable relational database. And at Single Store, I learned a lot about the low-level fundamentals of how databases work. And I learned how databases think about indexes and how they optimize and how queries are executed. And that gave me a lot of insight into sort of the advantages of the relational model and also the advantages of a real database.
Yeah.
So going forward to SQL Sync, what I felt is missing in the front end space is that sort of real database experience. It's about having a relational database that has indexes, that has all the advanced sort of SQL query features, and it's embedded directly in your application, and it's super, super easy to use.
Were the types of things you were building, like the user interfaces at Mixpanel, data intensive, visualization intensive? Do you think that having a database on the front end is the right approach for building those types of applications?
Yeah, if we look at historically, it wasn't really possible to put a full database. The
Uh-huh.
browser app sort of environment just wasn't capable enough to be able to do that. And so we always ended up with sort of shim databases in the browser, where
Yeah.
we would basically, for example, Redux is a really famous state management
Yeah.
library for React. And in Redux, you end up with an object of objects tree of data.
Yeah.
Maybe you have some arrays in there. And it works, you can definitely do this, but it's like a fancy caching layer. It's not a
Yeah.
real database. Why SQL Sync is very much like a real database, and we're basically saying that now the browser environment is capable of doing that. We have things like web workers, which allow us to run essentially parallel code inside web browsers. We have things like the Origin private file server system, which actually allows us to use proper block-oriented file APIs and byte-oriented file APIs. We have a lot of advanced more binary oriented types like uint8 arrays and stuff like that. And we're getting to the point where the browser sort of environment is a fully capable application environment. And so we finally can really build local first real database systems that run inside the browser.
One question that we got a lot in the early days of Gatsby is gosh, why now? And a lot of times we were look, JavaScript is ready, the front end dev stack is ready. It can do a lot of interactive things that were not possible 5-10 years ago. Now we're actually working on the data side of thing and the operation system type
Yeah.
capabilities that the browser has developed through the efforts of Chrome and all the other vendors maturing over the years.
Yeah, I think to me that's a major piece of why now.
Yeah.
Really the ability for SQL Sync to exist and other sort of browser-based databases to exist is a very recent thing in the browser environment world. But there's another set of capabilities that are also fairly recent that enable the backend to work the way you want it to work. So SQL Sync uses Cloudflare durable objects as its backend, and so Cloudflare Durable Objects is a magical technology. It allows us to run compute very dynamically, very close to the actual users who are connected to that compute. And so in the SQL Sync model, if you imagine SQL Sync being a bunch of SQLite databases, each of those individual SQLite databases is hosted by a different durable object compute node. And
Mhm.
this is all dynamic and automatic. And so the cool thing about this is that as your users connect to different documents, where those durable objects are running in the world will actually dynamically change based on who's connected to the document. And that is a foundational shift of how we think about backend technologies. Usually we think about backend databases as being one centralized thing running somewhere, probably in US East, like in Virginia, and that's it. That's your data model. And so we're fundamentally rethinking the backend as well as we're rethinking the front end to be more aligned towards edge first, local first applications.
Yeah, I think it's interesting in the sense of the thick client versus thin client, like network architecture, like changing so much over time. And in some ways, the cloud model is one model. And in some ways, this feels almost like now that we've gotten to the edge, we're re-enabling a kind of technology that was like, hey, we're going to run everything on our own, like in our own data center. But now every user in their browser is getting their own database somewhere. Like it's everything old seems to be becoming new again.
Yeah, it's totally true. And I think we can go even farther back to just if we think about how apps ran more than 10 years ago, most applications on your computer, like especially applications like Microsoft Word, for example, like they operated in a completely offline context. Like
Mm-hmm.
they had potentially no online features at all. And if they did have online features, it was probably at the level of like logging into your account and maybe getting some like status updates or something like that. But full data document synchronization just straight up didn't exist. And so in those worlds, there is this like interesting analogy that I want to talk about today, which is this sort of disk versus RAM analogy. And in those like old architectures where you have Microsoft Word running on your machine, when your file was saved to the disk, it was idle. Like it's just like a blob of binary on the disk. And when you load that file, we essentially materialize it up into RAM, into a whole bunch of data structures that allow Microsoft Word, for example, to actually operate. And most of those data structures are either reviewed for portions of the document, so like deserialized portions of the document, or they are data structures that don't need to be in the document, the saved state of the document at all. Like they're
Yeah.
just purely ephemeral stuff. And I think that even this analogy, like this
Uh-huh.
old versus new thing, is actually coming back. As we move to an edge first world, I think that there's an interesting sort of correlation where you can actually think about the edge data, like data living on the edge, as being the equivalent of the RAM in that analogy, where we materialize up from like
Uh,
save state, which might be running in like S3 or inside like a sort of more centralized database. We can materialize that up into edge server essentially to be able to enable super low latency operations and collaboration and all these sort of advantages, and then save it back down.
okay, so if I understand what you're saying correctly, what you're saying is that what we call the cloud now is essentially disk here. Your S3, your like GCP, your AWS, like whatever you've got. And then the edge is RAM. You're paging when you're creating a cloud application architecture on the edge that you're essentially paging your cloud into RAM as
Yeah,
necessary
exactly.
to enable your user to have really fast experiences, and then essentially shutting it off, I guess, when they maybe close the browser tab.
Exactly. And like a really good example of like why this is useful. Imagine a most collaborative applications you're used to. People on this podcast might have used like something like Figma, something like Linear, these types of apps. And if you haven't, just imagine a collaborative app. So you open up the application in your web browser, you're interacting, and other people are interacting at the same time. There's some features of those collaborative applications that we're probably used to thinking about. One of those features is like shared cursors. It's like a really common, fun feature that you can see what other people are actively doing. Another similar feature that's like more common in maybe more of a like a linear style architecture or like a Notion style tool is like just shared presence, just knowing what other users are currently looking at the same thing as what you're looking on. So
Yeah.
these two features are very interesting because I would argue that the state of these two features is very ephemeral. Like you don't need that state to be persisted permanently into the document. You only need that state to exist so long as people are actively looking at the doc. And like
Yeah.
once no one's looking at the doc, there's no need for that state to exist.
Yeah.
The edge versus cloud model enables that. In the edge, you can have these additional state layers like presence and like cursors and stuff like that that are only there to enable a better user experience, but don't really need to be part of your core disk model, your cloud model. And so
Yeah.
we can see that there's a difference there. So anyway, I think that this interesting like cloud versus edge thing is very interesting to explore. And so in SQL Sync, because SQL Sync's backend is running on like an edge function, SQL Sync provides durability, but it provides it by essentially synchronizing back to more of the cloud model. When SQL Sync is no longer being used, like no one's currently editing a SQL Sync doc or viewing a SQL Sync doc, we can actually just terminate SQL Sync because we can durably save the state of the document out to something like S3 or out to some Postgres database or whatever we need.
And I want to move forward to like when you're thinking about if you're thinking about starting an application, maybe you're working on an existing application that you're thinking of adding collaborative features to, like how would you think about the benefits of either SQL Sync or like the local first approach in general, and like whether it makes sense?
Yeah, so one thing that I've been framing as a way of explaining this new architectural paradigm is that local first databases mostly fall into what I call like document databases. It's not actually the same as like the traditional definition of document databases. It's probably a bad terminology. But I guess the way to think about it is if you think about Notion, probably most people are familiar with Notion, but Notion basically is like a collaborative wiki, right? You can think of each individual page on Notion as potentially like a document. I think that's a pretty rational way to think about it. You could either store like an entire Notion wiki into one gigantic database, or you could store all the individual sort of Notion objects as like essentially their own database. We could think about those two different models, and there's trade-offs on both sides of the space. Another good example is like Figma. Figma has a document model in the sense that like each Figma file, which is like a collaborative image editor, each image is its own document. If someone's editing one document, they don't need to see edits happening to another doc, right? They're independent objects. So most local first databases really work well when you have this sort of document style structure to your application. And the reason is that most local first databases don't do partial synchronization. They synchronize the entire object. So if, for example, you had Notion as a local first system using, let's say, an opaque, naive local database, you potentially would have all of the docs in the entire wiki exist in one massive object.
Mhm.
And this incurs like a scalability burden on the application because now two users editing different pages on Notion, for some reason, they're seeing those edits, even though the app doesn't need to know about that right now. We might need it later, but we don't need it now. So anyway, so long story short, I feel that like the current state of like local first databases is very suited towards these document architectures. And when you start to have systems where the document architecture doesn't like map as easily, it requires you to think a little harder about the trade-offs and figure out how to map your system into that document model.
Yeah, and it makes you think through your essentially sharding strategy or like your permission strategy a little bit earlier, like on a document level, or is it on a workspace level or whatever, because you essentially bake it into the application architecture in a way that's maybe a little bit easier to not have to worry about up front if you're sort of, hey, I'm going to run an RDS. I'm going to run an RDS Postgres instance, the way a traditional application might be structured.
Yeah, it definitely is more difficult. Like you might in normal applications with classic backend with normal API, it's essentially we've learned how to develop systems that essentially do partial replication. So you have one big consistent database in the backend, and each user is seeing a different subset of that database. And that like arguably can be mapped to the concept of partial replication, although most front ends don't do real replication. So essentially they end up being like a read through cache in the front end over some subset of the database state. And this architecture works, but it's difficult to it basically it's difficult to make like fully local first, and it's difficult to basically support like optimistic mutations on the front end and collaboration features and all this type of stuff. And so right now there's a pretty hard trade-off between like that model and the like local first model. Somewhere in the
Yeah.
middle is like a much more advanced local first model that allows for actual partial replication, where you have this sort of like singleton massive system on the back end, and then each user sees like a different subset of that system. But it's done in a like dynamic way. That's still, I think, pretty much an area of research, but it's something that SQL Sync hopes to achieve one day.
Yeah, what I'm hearing you say is that, hey, if you're building like an HR application with this user can see that you can see salary data, but like that user can't see salary data. Might not be the right use case for now. I am seeing a lot of local first applications in like collaborative drawing, collaborative editing, like you said, like document based models. Are there like other areas where you see like local first like architectures starting to emerge?
I think that we could talk about the HR case because it's an
Uh-huh.
interesting. So in
Uh-huh.
the HR case, as you like very correctly identified, is this problem of like visibility. Like you don't
Uh-huh.
want everyone in your company to see everyone's salary or their like SSN number or whatever. So you fundamentally need a model that allows for like visibility based permissions. One one interesting idea that I've started to play with is this idea of layered databases. So essentially, like we're used to sharding data like horizontally across like things like tenant, right? So
Yeah.
we're used to sharding being like each customer has their own shard. That's like a very easy way to frame sharding. But we could actually also shard data based on permissions, right? So we could say that like data can be essentially sharded across like a set of different permissions from a visibility perspective. So we have like admin data, which is only visible by admins. And then we have one layer down, which is your HR team data, which is like everyone in HR can see the HR data and also admins can see the HR data. And then you have one layer down and these like this layered model stacks. So like you have all these different layers. And we can think about sharding the data across that, and the local first document model could actually work for this because what you could end up having is you could have essentially a set of documents which each maps to a different layer of this sort of permission stack. And then in JavaScript, like on the front end, in the SQLite case specifically, like one convenient thing about SQLite is that we can actually observe all of those layers dynamically through a single SQL API.
Mhm.
And so there is a world in which we start to reframe even like how we think about permissions to be able to work better in these like local first worlds. It's a harder model. It requires a little bit more sophistication of how you think about sharding and breaking up your data, but it does work pretty well. And it gives you a very strong stance. Basically, you could basically provide like a very easy guarantee that anyone at like this level of the permissions hierarchy can never see anything higher because they can't even open the database. Like the database is just closed to them, which is actually easier to manage from a like, for example, like
Interesting.
a security perspective. It's easier to manage
Yeah.
at that super hardcore level of granularity than the normal case where like every API, like every REST API has to dynamically handle permissions and hide certain fields and show other fields based on who's querying the API.
Yeah, the model that you've chosen with SQLite is like very interesting because I think when in the sort of one big database, like everything in RDS, everything in this big Postgres kind of cluster, like the trend is moving towards like row level locking and pushing like finer grained permissions, not just from the API, but actually get them, try to codify them in the database. Whereas what you're saying is that because you're essentially thinking about lots of much smaller databases, you can actually push the permissioning level higher and say this database, that's this subset of data, it's not even row level. It's look, if you don't have this permissions, you can't even read from that database or
Yeah.
whatever might be.
And then we can do some really cool things on the local side. Because again, one of the advantages of the system is that we have the databases completely locally, which means that when the app is like asking, hey, resolve this query, and let's say the query crosses like three permission boundaries, like it says, get me like fields ABC, which is like universal, and then it asks for the person's SIN number or something. In this case, because all the data is local, we can resolve that completely locally. So we could basically say, if we have the like higher level permission database locally, then we just dynamically can merge that data in. There's no additional sort of like network cost that's needed. We just have a certain amount of data locally. We could provide like a really dynamic query architecture around this like layered system. So that's a different world than like our traditional model.
What's the strongest argument that you see for the local first architecture becoming more and more common?
So my argument, I think, is pretty well. Anyways, I think of it as like very straightforward. It's essentially we want no latency, we want reliability, and we want collaboration. Those are three things that we are starting to expect out of our applications. The no latency thing is a user experience that you can basically only achieve with local first. You can't if you have a network in your like if you have network as part of your sort of like hot path, which is like your API path, like you will have latency, and that latency can be extremely variable. You're used to testing your application with like localhost development. So as developers, we very rarely actually think about latency from the user experience perspective. But when someone from the other side of the world connects to your app and is like running over an API that's like central, you're going to have super high latency. So that's the first thing that you like have to think about. The second thing is like reliability is really important today. Like we want users to feel that like they can open their app and immediately start using it. And things like background synchronization should be a background process. Like that really is something that should be different from the user experience. Currently, we've conflated like the user clicking a button with like full-blown reliable data commit. And it's sometimes you want that. Like sometimes you want, like when the user says change my password, I do really want that to be a full-blown like end-to-end consistent thing. But in many cases, there are things you want to relax that requirement because you would rather optimize for the normal case where like it's going to eventually synchronize, the computer's probably not going to crash instantaneously. And then of course, like there's other things we can do to make that safe. So we can still have safety, but we can increase the reliability by order of magnitude by essentially minimizing how much network connectivity we need in the fast path or the hot path. And then the final thing is collaboration. We are starting to see collaboration show up in so many apps that we use on a daily basis. And it's almost getting to the point where like when you don't have collaboration, it's annoying. Oh no, I'm using an app that doesn't have collaboration. Like I have to email you this file. That is such an awkward concept. Or upload it to Google Drive, and then Google Drive doesn't support consistency management, right? So two people edit the same doc and you just get some random document state. It's either corrupted or it's like completely random. This is not a world that like we want anymore. Like consumers have now been like, okay, this is what we want. We want collaboration. We want everything to work. So we have to provide it. And there's one other little note on the collaboration thing, which I think is interesting, which is that more and more users are using multiple devices. That's a big one for like me, for example. Like I like my applications to synchronize across all my devices. So even for applications that are not multi-user, collaboration still helps our like current sort of state of consumers because it's really common for like, for example, I use a tool called Obsidian for all of my notes. And I love the fact that Obsidian synchronizes all my computers and my iPhone and my iPad all together. So I can always access my notes no matter which device I'm on at what time. So those are like the main arguments for the local first movement.
There was a point 2011, 2012 where there was a lot of excitement around HTML5, and Facebook built their app in HTML5, and then they had to port it back to like native apps because native apps had the performance that people expect and the reliability that people expected. And I think as a result, we have this divergent application architecture where Android, iOS, and web development are three fundamentally different tracks. And you feel how fast that linear is, and that's a progressive web app. No native code necessary. If we can build web applications using local first progressive architectures that feel like native mobile apps, we will have resolved this fragmentation of development effort and coordination that has plagued us for the last 10, 15 years.
I think that's a really good point. We're only starting to get to the point where the web platform is able to compete with the native platform. There's still things you can't do in the web platform that you can do in the native platform. That means that some kinds of apps will just not be ported until that changes. But it's becoming that delta is getting much, much smaller. With things like proper worker support across like different devices, things like proper sort of like ordered and private sort of file system support, WASM being like a major piece, or like WebAssembly being a major piece of it, we're getting quickly to the point where like there becomes like less and less reason to have a native app. And so a big piece of that is like data storage. We have to have really good, like modern, like data storage that works for the data models that we want. We need it to work like flawlessly in the web platform, and we need it to work cross device. So one thing about SQLSync that I'm really excited about is that SQLSync already works cross device. Like you can use SQLSync on your iPhone, your Android, your Chrome browser, your Safari browser. You get the exact same SQLite query model, the exact same replication model, networking architecture across all of those systems. And so suddenly your web app feels like a native app from a data perspective.
This is what makes me really excited about the local first movement, is watching all these things that we've wanted for so long, that to be real on the web, feel like they're reachable using local first technologies. What are things that like you would think about in terms of application architecture? What would be your checklist of think about X, think about Y, think about Z?
Yeah, that's definitely a pretty heavy question. There's so many things you have to think about when you're building an app. And a lot of those things you have to do with any app. Do all those things that you normally would be thinking about. At some point, you're going to come up with like your data model problem, which is like, how do I model the data structures that like back my application? Now, the correct answer to this is there's no correct answer. Like every single app has a different set of requirements. But if you have an app where you're like, all right, one set of features that I want in my application is like this local first collaborative experience. Like I've carved out like this chunk of the app and I've said, this is going to be collaborative. It doesn't have to be your whole app. Like I think it's the first thing to point out that you don't have to be all or nothing. Like I'm not going to try to reinvent the wheel. And the advantage of doing so is that all your framework stuff just automatically works. Like your backend stuff, you can continue to use the cloud the way you've been using it. You don't have to change those things. So good cases for not reinventing the wheel are things like your user database. Like the management of users in your system, you probably just want it to be consistent and simple and correct. You don't want to have to deal with eventual consistency and all these additional complexities when you're talking about who is allowed to do what in my system. Another example of a good high-level data model that you don't really need to be collaborative is metadata that exists at a high level. So like, for example, if you were building like a custom wiki like Notion, the database that contains which wikis exist and who has access to what wiki, like those high level metadata concepts, they also don't really have to be collaborative. Like it's probably okay that it's a slower API call that like creates a new wiki, because you want that to be consistent. You want to be able to do a bunch of stuff around that and make sure it's a really good experience. You don't want to have to deal with local first. So the first thing is figure out what portion of your app actually has to be collaborative, and feel free to make that a very small, tight portion. Once you've done that, now you have to ask like the question of is essentially what's your sharding layer for that model? Because local first works really well when we can actually synchronize the entire document state to every single user. And so we don't want every single customer to be in one gigantic local first document. We want to somehow shard it across probably customers and then maybe even a lower granularity than that. And so, for example, like we'll give some examples. So like in the Figma case, your natural sharding object is the per file sharding object, right? It's like for every single Figma file, we want to have one document that is collaborative. And so users editing different documents will be working on completely different collaborative data models. So that's like a good example of the sort of super granular approach. And then you can go a little higher. Like you could basically say, okay, I'm like building an HR app. So we're gonna shard across customers. So like we're gonna have one collaborative document for each customer, and then maybe we're gonna shard across permissions. So within each customer, we're gonna have n collaborative documents mapping to like permission layers. Like that could be a model that you go with. And then you need to think about is like how big are these documents going to get, and make sure that you are considering like the scales of things. Because if you shard everyone into a document and that document ends up being Justin Timberlake's like fan comments, suddenly you have one collaborative document with 100 billion comments, and that's not going to work very well in a local first architecture. So you do need to think about your scales, but that's true pretty much with any data model that you build. Like even a centralized data model, you still have to think about scale and thinking about like how you model things. But I think the most important thing here I'm trying to convey is start off by figuring out what portion of your app needs to be collaborative. And then within that portion, how can you shard across many collaborative states, like independent document states? And if you do that, then I think the local first model, like pretty much any local first system, whether it's SQLSync or another local first system, will map to that model really effectively.
That's awesome. Thanks for taking the time, Carl. Thanks for chatting and sharing your expertise with the community. Thanks for joining us.
Yeah, thank you so much. And I assume that you could put some like links to SQLSync and stuff like that wherever this podcast is shared.
We'll have some links to the different like pieces we talked about below. So thanks for joining us and have a great day.
Thanks, Sam.